And there's a good chance that you'll have time after we finish the lesson to start the homework and finish it up, because we don't have too many more problems that we're going to cover. Now, this problem here is the one that we finished up on, because we stopped at this problem here. Now, we went on and did this one because we could see that going from one to the other, that 6 times 2 gave us 12. 5 times 2 gave us 10. 8 times 2 gave us 16, so 4 times 2 is?
8.
So x was 8. And this one here, we could see the scale factor, because if we wanted to work it out, we could have said x over 4 is equal to, well, multiply both sides by 4. Well, 12 divided by 6 is 2. 2 times 4 is. That's all we'd have to do for that one there. But since we could see that the multiplication of 2 was the scale factor, we really didn't have to work that one out. We'll go on and move on to the next property, and that's perimeter. And what our property with perimeter is if 2 polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding lengths. So the perimeter of one over the perimeter of the other is equal to the corresponding lengths, the ratios. Well, let's just say 2, 4, 8, let's call it 4. And over here we have 4, 8, 16, 8. Now, if we compare their perimeters, so we'll put the smaller one on top. It would be 2 plus 4 plus 8 plus 4. The bigger one, we would have 4 plus 8 plus 8 plus 16. Now, if we add these together, well, the top, 2 and 8 is 10, plus 4 would be 18. The denominator, well, 4 and 16 is 20, plus 8 is 28, plus 8 is 36. 18 over 36 actually reduces to 1/2. So we're good with that so far, yes? Now, if I looked at any of the side lengths, we already saw that with the 1/2. Well, we can say 2 over 4. Well, that is 1/2, yes? Well, 4 over 8 is 8 over 16. 8 over 16 is still just 1/2. So the proportions of the side lengths are actually going to be the same as the proportions of the perimeters. So what that tells me, as long as I know one side length and the perimeter of one figure, I can find the perimeter of the other using these proportions. And that's what we're going to do with these here. Now, a town plans to build a new swimming pool. An Olympic pool is rectangular with a length of 50 meters and a width of 25. Okay, we have that here. $50 meters, yes. I mean, they can have more lanes because this only has 1, 2, 3, 5, 6 lanes at 25 meters. So they're normally a little bit wider, but they are 50 meters. Right, because it is 50 meters. Because if y'all have watched the Olympic swimming competitions, where they say 100 meters free stroke or 100 meters, whatever the stroke is, and they go down and back. Well, down is 50, back is 100. It's actually how far they swim. So 50 meters on an Olympic pool is just down. And that's actually quite long for 50 meters. 50 meters is quite a distance. Now, Yeah, and I think that's actually 25 yards. Yeah, because most pools are 25 meters. That one I think is 25 yards. They were wanting to convert over, but none of the other pools actually did. But looking back at this here, so the new pool is similar in shape. So it's also going to be a rectangle, but this time the length of the pool is 40 meters. And we want to find out what the new perimeter is. So find the perimeter of the Olympic. Perimeter, and we want to know the new pool's perimeter. Well, we can figure out the Olympics, because this is 50 and this is, because 25 plus 25 is 50, and a 50 is, so 100 plus 50 is 150 meters. Any questions on how we found the Olympic pool's perimeter? No, we like that kind of math, yes? Do we have enough information for the new one? Well, I know that these two are 40, yes? Do I know what the other two links are? No. But they are similar. So I can't just use the fact that I can add them up just like I did with the Olympic, but I can use the proportions like we did yesterday. Because I can say the perimeter of the new pool over what? 150, because that's the perimeter of the other one. Yes, the Olympics 150. We want the perimeter of the new one. So we say the new perimeter over 150 is equal to what over what?
40 over 50.
Yes. Width over width. Perimeter over perimeter is equal to width over width, because that's the only dimension they gave us, yes? Now what do we need to do to get x by itself? Multiply both sides by 150, yes. Now, this multiplication here is actually not too bad. Because really, we can say that we're dividing 150 by 50. How many times does 150 go into 150? 3, yes? Because 150 divided by 50 is 3. What's 3 times 40? 3 times 4 is 12, and we add the 0. So the new perimeter is 120 meters. That's it. Questions on this here? We ready for the next one? Okay, they didn't give us any pictures, did they, to go along with it? So let's see what we're talking about. Your neighbor has decided to enlarge his garden. The garden is rectangular. They're rectangular with a width of 6 and a length of 15. Yes? The new garden is similar. Okay, so it's also a rectangle. But we'll have a length of, find the perimeter of the original garden and the enlarged garden. Now, again, y'all are going to take the ACT again, coming up soon, mainly because, again, we want you to take it so that you're used to it, so that when you have to take it for the standardized test, y'all are comfortable with doing it.
Isn't the ACT count as the state test this year?
Yes.
So it's this test we're about to take, does it count?
Junior year is the one that it matters. So that's, for most of y'all, that's not this year, that's, but again, we want you to take it so that you're comfortable with taking in the timing and used to it, so you're not taking it for the first time when it actually matters. And on the ACT, because you took it last fall, they give you questions like this with no picture, yes? Y'all can draw on it. Give yourself a picture, because it makes it easier to work with. And if we look at this here, we're wanting to find perimeters, yes? Because that's what it's asking for. Well, the perimeter for the first one, 6, 6, 15, 15. So this year, the ACT that you'll take this year is going to count as an actual ACT. So if you do well, it can help you. You'll have to take it again in the spring next year as a junior. All right. As a sophomore, I don't think so unless you're in, I think, U.S. government, the history test. So we want to find the perimeter of the new one. Yes? Possibly, I don't know who is teaching it. Also, I think y'all are going to have to take the citizenship test. The test that, the naturalization test that every person who wants to become a U.S. citizen has to take. Y'all are required by Oklahoma to take it and pass it before you graduate.
Oh, really?
Yep. Well, why do we expect other people to know more than what about our own country than what we do? Okay. Now here we're trying to find the new perimeter, yes? And the original perimeter was? Now we need our proportions of sides. Well, they only gave us one side length of the new one. 35 over. Well, at this point here, we're going to need to multiply both sides by 42. Because we need x by itself. Because our original perimeter was because these will cancel out telling us x is equal to. We can put this in a calculator, 35 over 15 times 42, and get 98. So the new perimeter is 98 feet. And this is expected because, well, our original width was, our length was 15 and it went to 35. It increased, yes? So we should expect the perimeters to increase as well. This here is the exact same thing. Any questions on this here? Okay. I do want to look at these next two here for 14 and the one after it. Now these here, they didn't give us two polygons, but they did tell us the perimeter and their ratio, the side lengths as they compare to each other. So we're still going to use two fractions. So we want to find the perimeter x, and they gave us a perimeter of 66. Now the question is, are we going from smaller to bigger or bigger to smaller? Because what did they give us? They gave us the, so we're going to bigger, yes? Yes, because as we talked about yesterday, whenever we're going from smaller to bigger, our scale factor should be greater than 1 because the number should be getting bigger. And they told us the ratio is what? 3 over 4. So this isn't going from smaller to bigger, it's going from bigger to, so to go the other way, we would take it and flip it. Because as it's set up as 3/4, we're really looking at the equation of 66 over x is equal to 3 over 4. Well, if we flip it, it's going to work just as well. And here we just need to multiply both sides by. So here these would cancel out, telling us x is equal to. And that would be our perimeter. Questions on this here? Okay, we'll do one more of these here. So the perimeter of a larger polygon is 85 meters. We want to find the perimeter of the smaller one. Yep, 2 over 5, because we're going smaller, we need the smaller number on top. And we would need to do what? Yes. These here would. 34. Yep. And that's it. Because 85 divided by 5 is 17. We'd multiply by 2 and get 34. Questions on this here? This is the last thing we're going to cover is area of similar polygons. Now, when we think about perimeter, perimeter is always just in meters. Meters to the first, or units to the first power, yes? If I talk about area, area is in what? Squared. So the proportions of areas are going to equal our portions of sides, or our scale factor for the sides, our scale factor squared, because we're multiplying the lengths by each other. So its scale factor would also be squared. So whenever we look at the area, because area is in units squared over units squared, our side lengths are just in units, just basic units. So if it was area was meters squared, our side lengths are just in meters. And if we're going to compare proportionality or things being proportional, we need them both in square units. We need the units to be the same. So whatever our side lengths are have to be squared to get everything to match up proportionally. So if we're looking at this here, we want to find this area, yes? Still going to use the same type setup. We're going to have two fractions. I'll have the area of the 1 over what? Over 36, yes. And now we're going to use the side lengths to find out what the area is. 5 over 10, yes? But these here are in square units. Area of the first is in square units, centimeters squared. 36 is in centimeters squared, yes? The 5 and 10 both are just what? So this here needs to be squared. Because when we're dealing with area proportionality, we're going to square whatever the units are so that we get that ratio. Now, there's two things we can do at this point. One is we can go on and plug in 5 over 10 in parentheses squared to see what we get. If we do that, we would say that x over 36 is equal to, because 5 over 10 is what? 1/2. And if we square 1/2, 1/2 times 1/2 is 1/4. Now, we can do the same thing we've been doing. Multiply both sides by 36. 36 and 36 will cancel. And now we just got to take 1/4 of 36, which is 9. Figured it out. Put that in the denominator. That'll do it too. So we get this here. Any questions on this here? The other way we could have done this is just multiply both sides by 36. Type that in. Because that'd be the same thing, yes? Because the calculator would do the 5 divided by 10 first, square it, and multiply it by 36. And still tell us that it's 9. We can do it in either way. I don't have the other calculator up at the moment. So we could put 5 over 10 parentheses squared times. Type the whole thing in the calculator, will tell us it's 9. We don't have to do that simplification step, but we can if we want to. Okay. Any questions on this here? Let's look at one last one with area. And then we are done for today. Now, in the diagram, these two triangles are similar. And the area of RST is 75 square meters. We want to find out what the area of the other one is. So we're going to have x over is equal to 14 over 10. And this whole thing is squared. Now again, at this point here, we could type 14 over 10 squared into the calculator and simplify. Or we can just multiply both sides by. Because here the 75 and 75 will cancel, telling us x is equal to 14 divided by 10 squared times 75. And if we do this here, we get, that would be 5, 25, 3.
So why did you square it?
Because we're looking at the proportionality of them. Because for area, we're talking about units being squared. For our scale factor, just 14 over 10, it's just straight units. It's one set. Here we need it in 2. So we have to square that scale factor to match up with our area. Yes. And that would be it, because the scale factor for this here is 7 over 5. But when we square it, it'd be 49 over 25.
How did you give it up?
7 times 7?
No, you got the line exactly the same.
I don't know. Because 75 divided by 25 would be 3. 3 times 49 would get us to 147. And we would say meters squared if we wanted the units. And that's it. That is all we're doing for today.